Yeah, so thank you. My name is Davy. I'm going to talk about some things you should probably be thinking about related to automation and particularly large enterprises. So that's the space I'm in now. So that's what I'll talk about. One disclaimer, this is done on my own time. I'm not representing the company I work for, which I'm sure you can go find out on LinkedIn. Don't assume that anything I say you should do or not do relates in any way to what my employer is currently doing or not doing. So this is a little bit, I think, different level talk. I know there's a lot of technical people here. I actually can't talk in detail what about I'm currently doing. So this is a little more generic and a little more architecture level. That's not to say I couldn't get into some details. I spend all my days writing code for automation, so I'm definitely down in every level of detail. So I want to start with the why. Why are you doing this? How are you going to sell this to management? What are you going to deliver by doing network automation? You know, what's the value that your company's going to get, particularly, again, as I said, large enterprise. So I break this down into three areas. One is efficiency. And to be clear, not cost savings. If anyone comes up with a business case where automation is actually going to save you real dollars year over year, I'd love to see it, because I don't think that's possible. You're probably going to hire new people and spend more money, at least in the fairly short term. But it's about doing more with the same, about growing your network without growing your staff. I'd say one of the challenges, particularly in enterprises, is the infrastructure typically is not growing at a rate like a cloud provider, where you have to deal with how do I deal with this massive expansion of infrastructure, and that becomes a huge problem. A lot of enterprise infrastructure is pretty static, so there's a little bit of challenge related to that part of the business case. The other is velocity, right? Can I make more changes in the same amount of time? Can I make a change go faster than it went before? The challenge here is there are a lot of sort of non-technical timeline drivers, change management, right? Applications, business units tend to want to have priority in scheduling their changes over your infrastructure changes. Just because you can push a button and have the config push faster and validated faster doesn't mean you're actually going to make more changes in a calendar month. And last is reliability, which I think, in my experience, is one of the easier ones to sell, because people can sort of get this idea that I'm going to write code, I'm going to automate this. My configs are going to be more consistent, they're going to be more standardized, I'm going to reduce my human errors while I'm making these changes, right? No one's going to fat finger a command in the midst of doing this. And then the other thing I want to talk about a little bit is test coverage. So I think it's really easy for a manager to understand I'm going to write this code and do this. Unfortunately, this is probably one of the harder things to actually execute on and do well, right? If you're not scared that I'm going to write a piece of code and it's actually going to break more things than I break if a person's typing in at the command line, well, you probably should be, and think about that while you're building your code. So the next piece is the components. What should I be building or be thinking about building? And I break this down into three pieces, right? There's config automation. This is sort of the sexy thing that everyone wants to talk about these days. And then there are two pieces that are somewhat less sexy. One is network validation. The other is test automation. So on the config automation side, this is actually one of the more difficult things to do, except for your more simplistic use cases. It's also relatively high risk. You're actually making config changes to your boxes in real time, and you have a pretty good chance of breaking something if you do it wrong. And it turns out this is actually the most important piece for that reliability business case. If you're going to say I'm going to have fewer outages because there's less fat fingering, more standardization, you better be able to automate the generation of your configs. The other piece is validation, and by validation I mean, did my change work? I made a change to change the local pref of some BGP routes from 100 to 150. Did that actually happen? Did I not break something else in the process? This is less risk, obviously. You're only doing read-only commands. It's important for efficiency and velocity. What I've found is actually a lot of time is spent in operations trying to validate that the thing that I just changed actually worked, and did I not break something else? If you can push a button and have that answer relatively quickly, you can save a whole lot of time. The third piece, which I find a lot of particularly enterprises miss, is test. I'm going to make a change. Do I have a place to test that? It's actually very little risk, no risk at all, because you're not touching your production network. And actually is important to all the business cases. The challenge is it's actually a pretty large investment and a lot of work to do, and the payoff to that actually takes a fair amount of time. Now these things are actually related. So to do config automation, as other people have said, you need a source of truth database. You need to know what my network is supposed to be doing. If you know what your network is supposed to be doing, you can figure out whether your network is doing what it's supposed to be doing or not. If you have no idea what your network is supposed to be doing, it's a little hard to figure out whether it's doing what it's supposed to be doing or not. So once you have config automation, then you have a piece that you need for validation. Secondly, config automation helps you build test validation. So one of the things I often get from test people is, okay, I have this network, it's out there running, it has these 100 routers in it, I now want to go test that network in a lab. Can you build me some software that takes all those router configs, munches all together to deal with the fact that I have different interface naming and all these other things in my lab, and then spit out configs that are going to be in the lab. Well, if I have a source of truth to start from that the running configs are built off of, I can use that same source of truth to build a version of that that's going to build my lab, that's going to automate my test of that. So the config automation is kind of key to that. And then, of course, once I have this lab to do my testing, I need a test to run against that. Well, if I have validations that can say my change actually worked in the real network, I could run the same validations against my simulated network, and I should be able to get my validations. So that's sort of the hard level. So where should you start? There's lots of places that you could start. My opinion on where one of the nice places to start is validation, right? The risk is really low, and there's a lot of low-hanging fruit here, right? There's some companies out today that will do really complex mathematical validations of your network. But what you'll probably find is there are a lot of basic show commands you can get out of the output of that'll give you a really quick validation of whether a change worked and whether you broke something or not. And you can do those things pretty quickly in a sort of down and dirty fashion to get some value to your network operations and show that the money or the people that your management gave you to go do this is actually paying off and showing some value while you spend a whole lot of time building the other pieces of this that you need to build. And so some of the considerations around validation are, how fast do I need an answer? Like I said, there's some companies doing this really good mathematical validation of your networks, but if it takes 10 minutes to get an answer of whether I broke something or not, and maybe in some industries 10 minutes is sufficient, certainly in the industry I'm in right now, 10 minutes is not sufficient. You need an answer a lot faster than that. The other is, how sophisticated do your checks need to be? Again, if you can maybe run, say, 15, 20 show commands on your router that pulls all the data you need to do to get you to a 75% point of what you need, that is much better than trying to go build something that's going to get you 100% of what you need. Other thing is, how are you going to define the checks? I think network engineers are traditionally really good about doing a show command and filtering out tabulated output with their eyes really quickly to find the things that show you whether the thing worked or it didn't work. But how are they going to take that and then specify that in some sort of config file that gets run by operations that gathers the data and checks that? You have to figure out how you're going to get your engineers to define those. A couple longer term thoughts is, if I can define what behavior got changed by a config change, I should be able to define what the normal behavior is, because I have to define what the deviation from normal is. If I can define what normal is, then I have checks that I should be running all the time, not just when I'm making a change or periodically when I want to check things. And lastly is, it would be really great if I could just predict the impacts of what's going to change. I know what my behavior is supposed to be, I know how the devices are supposed to react. Tell me if I'm going to break something before I do that. There's lots of companies that make software to do this. There's a number of commercial options out there. It all depends on what you need. Building this yourself, other than the really kind of quick and down and dirty and fast thing, if you really want something complex, you want something immediate, it's actually a fairly large task, particularly if you want to do multi-vendor, you need a fast response and you want very robust checks. So I think test automation is probably the most overlooked piece of network automation. I think that because, at least in my past, 23 years of this, most people just skip this part of the process, particularly in the enterprise space. I'm going to make a change, and I'm just going to do it, and we'll see, and cross our fingers and hope it works. And I think historically that's because hardware was expensive when we had to build physical labs, and so it was really hard to get a replica of your network. That's all changed. VMs, containers of network images now. So there are a lot of other options. So I think this is an important piece. So things you need to think about, first you need to build a lab, right? I need to be able to simulate any one of my networks. It needs to be physical and virtual. Virtual is great. There's lots of great things you can do with virtual. There's lots of pieces you're going to miss. You know, iOS XR routers, V doesn't support QoS. You want to test your QoS, you better have physical routers. So it needs to be both. The other two big considerations are, does it have to be multi-vendor? And do I need to build a simulation larger than can fit into one server? If you want one vendor, you can go buy packages to do that. If you want a multi-vendor and you have limited scale, you can go use GNS3 or even G or any of those other packages, and you can do that. But if you want to simulate something that requires a cluster of servers, and you need it to be multi-vendor, you're probably going to be rolling your own. And if you know something that I don't, I would glad to hear about it. So then you can go basically spin that up, and if you have a good source of truth database, you should be able to spin that up automatically to build an exact mirror of what you have in production. Because hopefully your source of truth has a device inventory, it has topology about how those things are connected together, and all sorts of other great information that you can use to spin up a virtual environment that replicates your network. So then you have that, now you need a test harness. What does that mean? It needs to be, I need to simulate my external connections, my route injection, my traffic, and be able to simulate various impairments inside of that. So a whole bunch of VMs that I need to spin up that are connected into that environment. Now I have that, now I have a pretty good replica of my network, now I actually have to build test cases that are going to go test that. Again, if I've built network validation first and I know how to check that things are working as they should, and that my change made the variation to normal that I was expecting, I should be able to run that same validation against my simulated network in my lab. There's a whole bunch of test frameworks out there that are open source, various virtual network environments, commercial and open source, but ultimately there's a whole lot of do-it-yourself that you're going to have to probably put with this to actually make this a usable environment, which is the reason I didn't put this first, because it's a lot of investment to get to the point that you're actually seeing value. And of course, if you're not investing anything in tests today or investing very little today, it's a pretty heavy lift and a pretty big investment, both of time and money to get there. But my opinion is that actually the payoff is pretty great and the risk is pretty low. All right, so the part that everyone wants to talk about now, I've been doing this for 23 years, and when we talked about automation, most people weren't automating the configs. Back then, we're automating everything else around it. But this is the cool thing to do now, and there's a lot of value to this. The challenge is it's actually relatively hard. If you've actually done this in a very complicated, large environment. So I find a lot of people want to talk about, oh yeah, I want to go standardize this thing. My NTP, my syslog, my AAA, my SNMP. Fine, good, there's lots of tools out there, relatively easy to do, great place to start. The problem with that is if the use case, the business case you're selling is that I'm going to reduce human error, none of those things are user impacting if you break them. Sure, if I don't have my NTP config right, my timestamps may be messed up and I can't debug something when it breaks, but it's probably not going to drop packets that my users want to get delivered. Right? The stuff that really breaks things are the hard things. It's your L3 VPN config, it's your route policy, it's your BGP config. Those are the things that people are going to break and fat finger and take down your user traffic. Those are also really hard to build in an automated config environment. And so that's the risk that you're taking. If you're making that business case that I'm going to reduce human-induced errors, is you have to build the hard stuff to do that. And what makes it hard is multi-vendor. Go build a vendor-neutral data model that supports route policy that's robust enough to do what you want it to do, that'll work on 3 different vendors' platforms. Hard. Make that work in a way that so when you have to do multiple config pushes in a given order, I first need to add a VERF before I can add a BGP session in that VERF, or add an internet or an interface to that VERF, and I have to do a commit in between those. All those little idiosyncrasies of the different platforms make this piece quite hard. But the payoff is also there as well, if you can get it done right. One of the things to always remember is you have to standardize and simplify the configs first. If everything's a one-off and everything is 1,000 lines of route policy, you're probably not going to be able to automate that in a multi-vendor fashion. So
it's not just about automating, it's going to your network engineering groups and saying, okay, we need to figure out how to simplify how we're doing this so then we can automate how we do it. So there's incremental progress that can be made here, but you can't lose sight of the big picture because, again, if you're selling this based on reducing human errors, this is the ultimately the thing you're going to have to tackle. So several people have already talked about source of truth database, and this is kind of a key piece. There are, and it's the most overlooked piece of commercial solutions. There's commercial automation frameworks out there. And so they'll say, well, I have these templates, and we have these forms, and we'll generate the config, and then I'll say, well, where do all the variables come from? Oh, they come from your source of truth database. Like, I just have that sitting around, ready to go to plug all the data in. And if I don't, I can have one in a couple of months, and it'll all be working, and then I'll just plug the data in. That's actually the hard part. So you have to store everything about your network, right? All the variables. And as I said, as you get to more complex parts of the configs, there's lots of variables. And I need it vendor neutral, and I need it to be network wide. And like I said, this becomes a significant challenge. So when you start, you can say, oh, I can do Ansible, I'm gonna automate these smaller parts of my configs, I'll build these YAML files, put all my variables there, and that'll all be great. And then I go to find a route policy, and I have a YAML file that's 500 lines long, and no one wants to touch it because they're gonna break everything in the process, right? You have to have some sort of database of some kind. That database then needs to have a point-and-click web UI to it where people can put the data in there, or have a REST API to put the data in there, and it needs to have good validations around it to make sure you don't put bogus data in there. The other piece is, how are you going to version control this, and what's the process, right? You don't want someone to go change a config and have that pushed out when it wasn't really ready to be pushed out. So I need to process the version, every one of those data models. I should probably make a copy of what's in production to something that would go to like a staging status, make changes to that. Maybe I need approvals to that before that actually goes through. Do you want to put your approval process into that database as well, where people can sign off on the changes that are being made? Do I want a testing status of that, where it goes into my test lab to be tested, and then ultimately push that to production? So you got to think about all that versioning of the models. So if you want to go build one of these, one thing to look at is OpenConfig. So one of the nice parts, if you're not familiar with OpenConfig, it's basically a standardized config for routers. But the nice part is they've thought about a data model that has all the variables you would need to put into a router config or a switch config, and a structure by which to structure those. And it actually turns out that's a pretty nice blueprint to start with if you want to go build your source of truth database, especially for some of the more sort of comprehensive, complex parts of those configs. There are a bunch of downsides to it. The ISIS Yang model for OpenConfig just doesn't even compile, so you can't even get the data out of it right now. And it's missing pieces, particularly around route policy and other things. But it is actually a pretty good structure to start looking at. So one of the first questions I get is, well, what kind of database should you use? So you use SQL, NoSQL. I had someone come up after I did this talk a few weeks ago and say, we used a graph database, and I've done this in, well, not graph databases, but SQL and NoSQL, different systems multiple times. Pluses and minuses to every one of those. My opinion is it comes down to what do you have the expertise in, what tool set are you going to use, tool chain that's easiest for you and you have your developers for, because whichever one you pick, there's going to be downsides that you're going to have to do things to work around, but that's just my opinion. The other thing particularly, and I don't know how other people do this, but in the enterprise space, there tends to be a lot of workflow, and what I found in my past life is that workflow is really important. You can change underlying technology, really hard to change workflow. So understanding what your operational workflow is and how things are done is actually pretty important. Some of the things that have cropped up in the past for me are, how are changes made? You have some changes have to go through this change management process. They have to be done in the change window. Other changes happen automatically. How are you going to support both of those models, right? If you build this nice model that has version control around my database, it has to go through all these multiple steps, and now I have some minor change that gets pushed right out without going through all that version control. I have to be able to support both of those models. Do things have to go into test, other things not go into test, particularly multi-step changes. I need to make this, push this config snippet in, I need to do this set of validations, and then I need to put this other snippet in, and then this other snippet, and they have to go in a specific order. Someone goes into my source of truth database, they change 10 things in there. How do I force those config snippets that result from the changes of the source of truth database to get the right snippets in the right order so they go in the router and I don't break something in the meantime? This is actually going a little fast, so we'll have time for questions. A couple more slides. So the other question is, should I be using Ansible? And actually, when I first started using Ansible a couple of years ago, I asked folks in the room, and we had a number of discussions about this. And I come from a programming background. I have a CS degree. I've been a network engineer most of my life, professional life, and always have done scripting. And so when I first started taking a look at Ansible, my thought was, man, I could just do this a lot faster in Python. What am I using Ansible for? So Ansible has a lot of good things, and particularly if you're not a software developer, it gives you the ability to do a lot of things really quick. And we used Ansible when I first started a couple of years ago in our lab, and it was great. So getting show command outputs from devices, generating your configurations off the YAML files and Jinja templates, pushing those configs in with Napalm or whatever other module you want to use, up and going really quick. Lots of great stuff. Then you need to go have a source of truth database that has all these complex configurations stored in a vendor-neutral model. And you figure out that at some point, I'm probably going to use Python to query the database. And when that comes back, I have a Python dictionary usually of that data that came back. Well, if you've done things right, once you have the dictionary in Python, you're usually a couple lines of code from having a processed Jinja template with a config snippet. And if you've done it right, you're probably another couple lines of code away from pushing that into the router. And you go, where does Ansible fit into that model? Not so obvious, right? I don't necessarily want to go query a database, get a dictionary back, write that to a YAML file, and then use Ansible playbooks to process that YAML file against a Jinja template. I might as well just do that in my Python. So I think the more in-depth you get into things, and particularly if you have that skill set, like we do in our team around Python, you quickly get beyond what Ansible are going to do, or you find Ansible to be restrictive in a way to what you want to do. That being said, if you don't have a Python skill set or a database developer skill set in your team, there's a lot of things off the shelf in Ansible that are really great and get you at least through the first 2 steps very quickly. So my last slide, what about commercial automation frameworks? There's a number of them out there that I've looked at. And there's some good ones out there. My challenge always comes back to the question of vendor lock-in, which is really around how much effort and calendar time are you going to spend building inside that framework, and then how much specialized knowledge you're going to have to build around that, right? I haven't seen anything out there in automation that I would take off the shelf and with a couple of people in a couple of months be automating my network. There's a lot of code that needs to be built inside of these frameworks. So if you're going to get 5 developers on board and spend 9 to 12 months building something in a proprietary framework, and that framework goes away, or that framework becomes too expensive, how long is it going to take you to write that back out on your network, and how much is that effort? And that's always, for me, wherever I've been over the years, a hard sell. Where if you want, I always picture it as sort of the core and the edge, right? In the core, you have your source of truth database, and some of these key components that go around there. You want to have that based, in my opinion, on open source in your own code. And then you want the ability to plug things in with REST APIs around the edges of that, whether that be monitoring software or other tools. You maybe want to drive your monitoring software config off of your source of truth or other things like that. But the center of that, your database, your core logic, very difficult sell always has been for me to build that around a commercial product. All right. Questions? Hopefully there's lots of questions, otherwise we're going to be way back ahead of time. All right, so the question is, if you have data in an open config model, how do you get that into your database? That's not actually what I was talking about here. So what I'm talking about using OpenConfig for is a blueprint for your data model in your database. So I need a set of tables, I need a set of columns in those tables, and a set of relations between my tables. If you look at the Yang model for OpenConfig, it's very close to looking like describing a SQL database. And so you could think about how you automate that process of saying scripting, pulling the Yang model of OpenConfig, and creating database tables out of that. It's actually, in my opinion, just quicker to go manually look at that and go code your database, as opposed to any sort of scripted process to do that. Because it's a one-time process, right? I need to do a one-time conversion to from one to the other. I mean, you could also look at things like Yang bind, where you build your Python bindings off of the OpenConfig Yang models, and then taking that Python code and trying to translate that through like an ORM into your database, like a SQL algorithm or something into your database. The problem is Yang bind creates a lot of completely human unreadable code of Python. It's really hard to do much of anything with. Does that sort of answer your question? All right, we can talk more afterwards. Other questions?
You mentioned a versionable database that can kind of go from staging into production. And are you aware of anything like that that's not custom built today?
No.
Easy enough.
If I did, I would go build one.
Okay, cool. Any more questions?
Yeah.
You talked about kind of the big payoff with auto-generated configuration. We've actually seen, maybe not a huge payoff, but just the ability to form network statements with the IP addressing module and getting rid of that fingering of the network statements has actually been surprisingly a bigger factor than I ever thought it would have been, and a big plus for some of the efforts I've been involved with the big automation. Any other little low-hanging fruits like that you found?
One of the things that we sort of looked at first was we spent a lot of time shifting traffic away from production elements to do maintenance, right? And so circuit maintenance comes up, we want to preemptively shift traffic away from that. Router upgrades coming, you want to shift traffic away from that to the redundant elements. I think that's a really great candidate for automation, especially if you can just turn over that to your operations, and someone can just push a button and have that happen. So yeah, I think there's a lot of low-hanging fruit on the config automation. I just think from what I've seen, some of the more complex things are also the bigger payoffs. I think network statement's a good example. But as you get to the hard pieces, it does get.
You're right. The configures starting to look like programs in and of themselves, right? What region are you in? Okay, I need this chunk of code, right? Yes, I know what you're saying.
When you get to a large, complex network, there's so many different variations by route policy in one region on one type of router versus a different type of router on a different region. You got to catch all those intricacies of that. And then also, the other thing to think about is, you can build a lot of your business logic into your templates, into your config templates, your Jinja templates. But then once you do that, as soon as you want to take, say I have a Cisco router in this part of my network, and I have another team in a different part of the network, and they want to reuse that, then none of that code becomes reusable because I just baked a whole bunch of business logic for this part of my network. Instead of putting it in a source of truth database and actually pulling that in, I just hard-coded a lot of stuff right into my templates, and then the templates aren't reusable. So I go in the WAN and I build a template for an iOS XR router, and I hard-code all my BFD timers in there for a WAN, and then someone wants to deploy that router in the data center and they want to do their BFD timers differently. None of that Jinja template is going to work. They have to rip that all up, at a minimum, edit the heck out of it, if not, sort of recreate that. And so you got to think about sort of reusability as well.
Yeah, so I was wondering if sure, it's going to be organization specific and very often it's going to be bad or no. Have you had any luck? So there's the features that you can she said automating or low-hanging fruit, where there's also, there's a way of accomplishing a certain task that might be easier to automate, but might not quite so strictly adhere to the ideal expression of business logic. Have you had any luck trying to constrain the designs that get implemented based upon what can be easily accomplished here?
Yeah. So the question was, let me see if I can rephrase this. So the question was, can you basically, constrain sort of the inputs to your sort of business logic to accomplish some of this kind of low-hanging fruit stuff.
Build things that are easy to automate instead of trying to automate the hard things. To the extent.
Yeah. So absolutely, build something. If you start by building a network that's simple, it'll be much easier to automate. And this, I don't know, I spent a lot of time in enterprise. I don't know if this is enterprise specific, but I don't know how many network engineers say, okay, we need to standardize this across all of these, and they'll say, there's no such thing as a standard. Everything's a one-off. We can't do that. No, you kind of have to do that. Or everything can't be a one-off. And then especially when you get to large engineering teams, there's so much of this engineer does it a little bit different than this engineer does it, especially when you have very large teams spread across a large geographic area. You have to rein that in first, right? It has to be simple, it has to be standard. And if you don't do that, don't even attempt to automate those pieces because it's not going to work. And I think, traditionally there's been a large sort of resistance from particularly enterprise network engineers to doing that sort of thing.
Great, thank you, Matt.